Following on from the previous video, we can convert from Cartesian coordinates into polar coordinates by making this demand. And in order for the dA to make sense, we need to stick this r in here. And we've already seen why that's the case. We can accept it by now. I'm expecting you to be able to accept it by now. Well, this r here is called your Jacobian. If you're working in cylindrical form, to convert dV, you would need to stick this r in here. Well, this r here is called your Jacobian. In spherical form, your dV here becomes this weird complicated thing here, and this bit here is your Jacobian. And in order for you to understand the in order for you to fully understand the Jacobian, you would need to take a more advanced course than Calculus 3. But for the time being, in the next video, I will give you a rough explanation as to why you would have this weird thing here. But for you to fully understand the Jacobian, you need to take a more advanced course than Calculus 3. But in this video, I'm going to explain the spherical coordinates. So in the next one, I will explain why you have this weird thing here. For you to fully understand it, you will need to take a more advanced course. So let me explain the spherical coordinates. So in spherical coordinates, we would use spheres to reference any point in 3D space. So let's say we want to reference this point here. Well, the radius of the sphere is rho. So this is your rho here. And when it comes to spherical coordinates, you always specify the angle phi with the angle that it makes with the z-axis. So we would always specify this angle phi. Well, if you want to know the height of that particular point, which is z in our case, if you want to know the height, hang on. So let me just. So this here is our radius of our sphere, which is given by rho. This angle here is phi. Straight down. So now you've got a right angle triangle here. If you want to know the height of that triangle, which is this height here, well, the height of that triangle is the same as the height of this triangle here. So this is your z. This is your z. That's your z here, and this length here is also your z. So let me just look at this triangle here. So this triangle here looks like this. Hang on. So this is the radius of the sphere, which is this here, rho, and this is your angle phi. That's this angle here. Well, you want to know the height, the z value, which is the height. Well, this z value here is the same as this z value over here, which is you using cos. So this is cos. So if you want to know z is given by the hypotenuse, which is rho here, and then cos phi. And then if you want to know, hang on, so this makes a right angle triangle here. So we know z. If you want to know the radius r, remember the radius of the sphere is rho. The radius of the, well, remember in polar form, this r represents a radius on the xy plane. The radius of the sphere is different from our radius on the xy plane. Well, if you want to know r, well, looking at this triangle here, right angle triangle here, this angle here is phi. We are working with phi. We want to know r, but we can only work with phi. Well, phi, phi, this is our r here. This length here is the same as this length here. So rather than using this triangle, we would use this triangle here. Well, hang on, let me just redraw this triangle here. So you've got a right angle triangle here where we want to know r. This length here is the same as this length here. Remember, we are looking at this triangle here. So this is our rho here, and this is our angle phi here. Well, r is really sine phi, rho sine phi. So this r here is the same as this r here. So r is given by this. Now once you know r, you can always work out the x value. It would be, so remember this angle here is theta. That's this theta here. So once you've got that angle, once you've got the hypotenuse here, x will be given by the radius, which is the hypotenuse here, and then you've got the angle theta here. So it would be cos theta times the radius, which is this thing here. That will then give you the x length. And if you want to know the y length, the y length will be given by this, because hang on. Remember, we know r here. R is given by this. So this length here is given by rho sine phi. If you want, remember the y value here. This y value here is the same as this length here. So if you know the, hang on, let me just draw this triangle here. This triangle here is given by, hang on. Well, this, you know the radius here is given by this, and you know the angle theta. Therefore, you should be able to work out the y value here. The y value is given by this. So if you want to work in spherical form, all the x's will be replaced with this, all the y's will be replaced with this, and all the z will be replaced with this. And you need to see some examples, which I will show you in the future. But to make the transformation, we would replace all the x's with this, all the y's with this, and all the z's with this. In the next video, I will explain why. I won't fully explain it, but I will give you a rough indication as to why when you convert dv into here, you would have this weird thing here. Okay, that's in the next video.